Hello, I'm Dr. Gleisner, and this is the Hidden Science Show, Atoms and Forces. Why do atoms exist at all? I'm going to address bits which are missing from GCSE Science Chemistry. What you learn about forces at GCSE is that the nucleus comprises neutrons and protons with electrons orbiting around the nucleus in shells. You also learn in physics that there are two forces which act at a distance, magnetism and electrostatic attraction. In fact, magnetism and electrostatic attraction are actually part of the same thing, the force called electromagnetism. Moving charges such as electrons going through a wire cause a magnetic field to spring up. In essence, wires carrying electricity become magnetic, and of course when you move a magnet about a wire, you can push electrons along the wire, generating electricity. We also know that in magnets, opposite poles attract, south and north attract, and same poles of magnets repel, such as north and north. And in electrostatics, opposite forces attract, positive and negative charges, while the same charges repel. Positive charges repel positive charges, and negative charges repel negative charges. In an atom, you have protons next to each other, and around the nucleus you have electrons. So why do atoms not lose their electrons since they repel each other, and how come the nucleus survives repulsion between positively charged protons? Now, it is quite straightforward to predict that electrons are going to spread out in orbit around the nucleus and will try to occupy as much space away from each other as possible, while still being attracted to the nucleus. At a given distance, you can therefore only put so many electrons. This is why we have shells. The first shell, which is closest to the nucleus, can only hold 2 electrons. The next shell, the second, can hold 8 electrons, because at a greater distance it occupies more space. The third shell can, according to the GCSE specification, hold another 8 electrons. This is actually not completely true. It can actually hold 18 electrons. You would expect this to be the case, since it is further away still than the second shell and therefore offers more space. The third shell is split into 2 parts by the fourth shell, for reasons I won't go into here. So the true order is actually first shell, 2 electrons, second shell, 8 electrons, third shell, part 1, 8 electrons, fourth shell, 2 electrons, third shell, part 2, 10 electrons. However, this takes us well beyond 20 electrons. We only need to be able to cope with 20, so the 2-8-8 rule is fine. In fact, you could quite correctly call it the 2-8-8-2 rule, which fairly describes the first 4 shells, albeit not completely, since parts of the third shell are missing. So as I said, GCSE science isn't wrong, but it is simplified. But there's an obvious question about the nucleus. If you have lots of positively charged protons, should they not repel each other? And the simple answer to that is yes. So why don't they? And the honest answer is that we didn't know until relatively recently, 1979 in fact. In science you often observe something and know that it is real, it comports with reality, without having an explanation for it. Sometimes it seems that in science we have an answer ready-made for a phenomenon. In truth, we get the answer usually later than the postulation of a fundamental requirement. What I mean by this is that we can, for example, observe gravity and we can test it. But what actually causes gravity? I'm going to return to the nucleus. In the same way we observed from the Rutherford-Geiger-Marsden experiments that atoms have a positive nucleus, but we didn't know how it held together. So how do we know whether something is fundamental or not? Well, I will give you an example. Remember the electrostatic force and the magnetic force? They were thought to be independent, and the suggestion was that they were 2 separate forces. It was only later that it was discovered that they were part and parcel of the same phenomenon, electromagnetism. So because we observed that nuclei are held together somehow, there had to be a force holding them together, since electrostatic forces should have forced the protons in the nucleus to repel each other. Not only that, but because the nucleus was well defined in space, in other words, protons were really close together, we knew that this force acted over a very short range, and because electrostatic forces become much stronger the closer charged particles are, it was incredibly strong. So a fundamental force was proposed, the strong nuclear force. Just a quick aside. As particles were discovered inside protons and neutrons called quarks, the possibility of new particles became feasible. Some new particles were found, others proposed and either found or not. Neutrinos were such particles. Since the phenomenon of nuclear decay was well known, a new mechanism was needed to explain that. So the weak nuclear force was proposed. So far, it seems that we can explain the universe sufficiently well with those 4 forces. And an aside to this aside, dark matter and dark energy are equally a result of this need to explain things we cannot explain, and until recently there were no mechanisms to even measure anything dark. Back to the atom. So over very short distances the size of a single neutron or proton, you have the strong nuclear force holding neutrons and protons together. Don't forget that they are made from particles. At the range of nuclei, it is the residual strong nuclear force which keeps nuclei from disintegrating. At the range of atoms, it is electrostatic forces holding electrons and nuclei together. And there we have it. In science, we know of 4 fundamental forces, and 3 of them are needed to keep atoms from disintegrating. Please like and subscribe, and let me know of any questions you'd like me to cover in the comments.